Hello everyone. Today we're going to solve another engineering dynamics problem step by step. So, what is our learning goal for today? We have finished our chapter 12 to chapter 14. We're going to start our chapter 15, and today we're going to cover chapter 15.1 to 15.2 of our textbook from Hibbler 14th edition. So in this section, we're gonna cover the principle of impulse and momentum. So we're gonna use our principle of impulse and momentum that we have learned from our theory section of the video, and we will solve using that problem. Well, in addition, we will also see how the knowledge that we have learned in chapter 12, 13, and 14, can we still solve the problem using that concept? Well, that may not be applicable for all problem, but for this problem, we still might be able to solve using the concept from chapter 12 to chapter 14. And next, we're going to show the solution of this problem using chapter 15. And in the process will be detail and step by step, and I will be asking question and answer myself so that you can develop the skill how to start the solution, how to progress towards the solution, what would be the step by step towards the solution. So let's start our solution. So the first step is to clearly understand the problem and find out what are the given and what I'm looking for, what I have to find in this problem. This problem says a 50 kilogram crate is pulled by a constant force P. We can see in the image it is pulled by P towards right. Starting from rest, the crate achieves a speed of 10 meters per second in 5 seconds. So the velocity is 10 meters per second, and it achieves that velocity within 5 seconds from 0. If the kinetic friction coefficient is 0.2 between the crate and the ground, determine the magnitude of the force. So the first step, without thinking, I'm going to find out what are the things are given and what I have to find. So given are the mass of the crate. It starts from rest, and at t equals to 5 seconds, the velocity is 10 meters per second. So there is a change in velocity. What happens if there is a change in velocity? Yes, there is some acceleration involved. So there is a hint here that we know there might be or must be an acceleration involved. Otherwise, there will not be change in velocity. Okay. We also have kinetic friction, suggesting us we have to assume kinetic or use kinetic friction force at some point in our problem. What we're looking for? We have to find the force required that needs to be applied here for this scenario. So now, how do we start? Where should we start? As we said, we're going to solve this problem in two different ways. First, using the concept that we already know from chapter 12, 13, and 14. And next, we're going to solve it using the concept of 15.1 to 15.2 of chapter 15. So in the first case, we're going to use the concept from chapter 12 to chapter 14. See, in this problem, we're looking for a force P. Force, so that's one thing. We have a force. And starting from rest, we have a change of speed with the 5 second time. So there's also an acceleration, right? So change in velocity gives you acceleration. So I have acceleration. And force into acceleration, what are the relationship between those. I also have mass, m. So FAM, does that click something? Oh yes, we can use equation of motion. Summation of force equals to mass into acceleration. So the next question is, how can we apply this equation to this problem? Or can this assumption that this equation can be used will lead us to the solution? We don't know yet. So, but it looks like we have all the things we need for this equation, so we can proceed. First thing, we know our acceleration. How do we find our acceleration? Change in velocity, which is 10 to 0 within time 5 seconds, so it is 2 meter per second squared. So I get a hint that, okay, I know these unknowns. Do I know mass? Yes, this is given. So all the unknowns are on my force side. So I don't know what are the force acting on this problem. So how do we find what are the force acting on the problem? What are the way to figure out all the force acting on this body? Right, we have to draw a free body diagram. In a free body diagram, we should show all the force acting on the body. In this crate here, there is a mass of the crate, so there should be a weight acting downward. Since there is a weight, there will be a normal force of the ground on the crate, so there is normal force. The problem also gives us the friction coefficient, kinetic friction coefficient. So there will be friction force since the body is moving, P is on the right direction, this on right. So the friction would be opposing the movement. So the friction force kinetic would be opposite, while my P, the pulling force, is towards the right, and that is angle in 30 degree. Is there any other force that we need to consider? On my left side, summation of force. No, because there is no other force acting. So on my right side, I have mass into acceleration. On my left side, I have these forces. Now, which direction I should use my summation of force? I can do summation of force in x. In that case, I can do summation of, my right says max. I can do summation of y and may, or I can take summation of force in this direction. So I have three options. Well, which one I should choose? This one is a little bit difficult because you have to take all the forces acting along this direction. And we'll start with the easiest one, summation of force in x or y direction. We may have to use both equation because the more equation you have, the more unknown you can solve. So here we're just doing our outline. How do we start our problem? We have planned out, again, we had force, acceleration, and mass. We figured out this equation has connections. And we draw a free body diagram. Looks like we have all the forces we need. So now we can proceed towards the solution. So first, I start with summation of force in x direction. So in x direction, I have the forces P and its component, which is 30 degrees. So I'll have P cos 30. And I have the opposite direction, friction force, kinetic friction force. I put F mu. And on my right side, I have mass into acceleration in x direction, AX. Now, can we solve this equation? I need to check what are the things that we know and what are the things we don't know, which are in terms of variables. Cos 30 has a numerical value, so we know this. F, what is kinetic force? Yes, we know it. It's normal force multiplied by the coefficient of kinetic friction. So we still have unknowns. So we don't know what is P. I have one unknown. We don't know what is N. I have two unknowns. We know what is M. Do we know this? Yes. It is 50 kilogram. Do we know the acceleration in x direction? Yes. We just figured out it's 2 meters per second square. So this is we know from previous slide. So we still have two unknowns, P and N. Can we solve this equation? No, because one equation can solve one unknowns. To solve two equations, I need two unknowns. So what should we do now? Right, we have the other option, the summation of force in y direction. So in our equation of motion in y direction, we have summation of force in y direction equals to mass into acceleration in y direction. Since the cart is not moving upward and there is no acceleration in y direction, what would be the value of AY? You are right, it would be 0. So since this is 0, these terms cancel out. So I can put 0 on my right side. What are the force acting in y direction? If we look at our free body diagram, how many forces are acting in y direction? There is 3 forces. Normal force acting upward, we take the upward force positive, and the previous one rightward towards right force positive. So for y direction, normal force acting upward, weight is acting downward, and we know weight is mass into acceleration, so mg. And we also have a consideration we have to make about the force P, because it is an angle and it has some component in y direction. So how do we find the component of P in y direction? You're right, we have to do P sine 30 degree. Are these all the force we have to consider? Yes, because there is no other force acting. So from this equation, we can say N, the normal force, is equal to mg, because I'm taking all these terms on my right side, minus P sine 30. So once I have N, now I have two equations. One is this one and another is this one. Now I'll not do the math part because you can just plug the value and get the result. So from how do we find N? You know M equals to 50, G equals to 9.81, P we don't know, sine 30 degree you can know it's a numerical value. So all we have to do is plug the value of N from here, this part, and put here as replace the N here. So this equation 1 will have only unknowns P and this P, and we know mu k is 0.2, so we have only one unknowns from this equation. And if you solve for P, you will find P equals to 2.5 Newton. So that's your part. Now just use this equation 1 and 2 and plug those values that I told you and check if you can find the value P equals to 205 Newton. That would be our answer of this problem using the concept of chapter 12 to chapter 14. Now we're going to do some advanced stuff. We're going to use the principle of impulse and momentum from chapter 15.1 to 15.2 to solve this problem. So the next question is, how do I know that if I can use the principle of impulse and momentum to solve this problem? Well, let's look at our principle of impulse and momentum. Change in momentum, which is mass into initial velocity, plus is depend. So initial momentum plus the impulse. You know the impulse is force acting over a certain period of time. So mv1 and mv2 is the change in momentum, which would be equal to the impulse. So if I take the mv1 on the other side, so I have mv1 initial momentum plus the impulse would be equals to final momentum. Let's examine the equation more rigorously. I have mass given, I have the initial velocity, I know it's rest, so it is cancelled out. v1 is 0 because it starts from rest. I have v2 is 10, and I know the mass, so only unknown is this f. Can I still use this principle of impulse and momentum? Well, the problem says a force P is acted over a certain time, which is 5 seconds. That means I can still use this equation. Force acting over a certain period of time, dt. T1 would be 0, T2 would be 5. So I can still use principle of momentum equation to solve this problem. So now let's apply the principle of impulse and momentum in our problem. We know we can solve again apply this principle in directions of x or y. We can start with in x direction because our body is moving in x direction towards right. So summation of the initial momentum mv1, which would be 0 because it starts from rest. We have on the other side v is 10 in x direction and mass is 50. So we can say it's 500. Now, this is the impulse force into time, and we have summation, meaning we have to consider all the force acting on the body. So again, on our free body diagram, we have the force P acting, weight acting downward, normal acting upward, and friction force, kinetic friction force acting on the left side. So we have kind of 4 force to consider, but on x direction there is no weight and normal force, so we have only P and F, component of P force towards x direction and the friction force. So if we write that on this part, we will have P cos 30 degree, that is the x component, and dt. How is the time? What is the total time? 5 seconds, so multiplied by 5. And what other force we have? We also have the friction. Friction is what? The friction force is negative, and it is normal force multiplied by the kinetic friction coefficient, and this force also acted for 5 seconds, so multiplied by 5. So we have 0 on the other side, and this is the equation. Now, can we solve from this equation? Same problem as previous. We have 2 unknowns, n and p, so we cannot solve. And what we can do, we can apply the principle of impulse and momentum in y direction. So if we also apply the principle of impulse and momentum in y direction, assuming the upward is positive, we will have mass, velocity 1 in y direction. It starts from 0, so 0. There is no velocity in y direction at the end, so it's because the crate is moving only along the horizontal path. There is no component in y direction, so this velocity is also 0. So all we have to consider the forces in y direction. In previous step, we consider all the forces in x direction. Here we're going to apply all the force in y direction. So what are the force in y direction? There is normal force upward, so I put normal n, and it acted again for 5 seconds, so multiplied by 5, so it is 5n. There is also a component of the p force. Since it is 30 degrees, so I will have sine, P sine 30 degree, and it acted for 5 seconds. And we also have the weight downward, right? So weight is mass into gravitational acceleration, mg, and it also acted for 5 seconds, mg multiplied by 5. We can cancel out all 5, and you will see, divide both sides on 5, and you will see the same n equation that we solved for previous option. Previous way we solved the problem, n would be the same. Now if we plug this value of n from this equation back to here, and if you solve, you will get P equals to same as 205 Newton. So now your goal would be apply the principle of impulse and momentum by yourself, and use the equation in x and y direction, plus use those values and check if you got P equals to 205 Newton. If you have any question, and if you feel any trouble solving and getting the result, if you need more clarification, please comment below, and I will explain in reply to your comment. So next we're going to solve other problem that will be in next video. Hope you have enjoyed it and understood how to solve this problem. Thank you.